Welcome. In this lecture, we will be studying the data types that we use in data mining. So, these are the basic types. First is numerical, categorical, time series, text and images. So, let us go to the first. Numerical. Numerical means any digit that we use in real life. For example, 1, 1.5, 2, 2.5, and numerical can be partitioned into two classes, discrete and continuous. Discrete is such that you have integers. For example, how many faces of a cube has, how many kids are playing in a garden. So these numbers are discrete, and when it comes to continuous, it can be anything in a range. For example, what is the height of a person, and it should be between like 5 feet to 10 feet. So it has a range that we specify. So these are the numeric data types. Categorical. Categorical means you are given some data and you need to define the categories. For example, the category is a state. For example, a post office, whether it's open or closed. It could be labels. For example, I give you the images and you need to classify which object is in the image. It could be a chair, it could be an animal, it could be a bird. So these are labels. Also, we can represent these labels by numbers. For example, if I need to do like whether it's a right hand or left hand, so I can represent left hand by 0 or 1 for right hand or the otherwise. So we need numbers to represent these categories. Next comes time series. So time series is an ordered collection of observation. Order is specified by time. For example, revenue of a company throughout some years. So for example, we have a year 1991 and then the revenue is 10K, and for 1992 we have 12.25K revenue and so on. So this order collection is your time series, and this order collection could be your numbers or anything else like state of sleep. Suppose I am sleeping and some system is monitoring the quality of my sleep. At some point at 8 a.m. I could be awakened, at 8:30 p.m. I am in a mild sleep, and then I am in the deep sleep. So this is a time series. Next. So the real examples of time series are like weather monitoring systems, the revenue hourly, quarterly, or the temperature hourly, yearly, monthly, bi-monthly, and the traffic on a website hourly, weekly, like this. So these are all time series. Then comes next is text. So this is the main application is related to natural language processing. In the text data, we have some data, for example, in English, and we have some objectives. For example, we need to find what are the entities in the text. If I give you the sentence, Raj bought an Apple iPhone, so Raj would be a person and Apple will be an organization. Or if I give you the text, you may be interested in what type of text is it. It could be a political document, it could be a sports document, or it could be anything else. And there are some other applications as well. For example, I want to translate one language into another. If I say in Swedish, Jag är Rajkumar, so it should be translated in I am Rajkumar. So these are some basic applications that we do with text data. Next come images. So when we talk about images, it's a digital image. We often talk about digital image, and the digital images are a set of ordered collection of pixels. They should be discrete and finite. And when we talk about images, we normally see three types of images: a color image, a grayscale image, and a black and white image. This is an example of color image. You see so many colors, and on the right hand image on the right we see the pixel values, and for each pixel we see 3 values. These 3 values are your color for red, green and blue content. So all the natural colors that exist in the nature, we can derive them by varying the quantity of red, green, blue. So this is your color image. Next comes grayscale image. As you see in the middle figure, we have a black and white image. We call it black and white in layman language, but it's a grayscale image. And if we see on the right, we see some pixels, and each pixel is having only one value, so which represents the shade of these black and white colors. So there are only variation of from white to black. The binary image, if you see here, this image only has 2 colors, either perfect black or perfect white. The perfect black color is represented by 0 and perfect white is represented by 1, as you see in the figure in the right. So it shows you that each pixel is having only single value, either 0 or 1.